Well, thanks for giving me a great out. My name is Ryan Cannon. I work for the NFL's digital media group. I'm manager of application development there, which means I run our front-end team that does most of the NFL.com and some of our other sites. So this summer I was given a challenge. I was asked to join forces with the club sites team in a separate business unit and transform the NFL's existing video experience into a multi-site video platform. We were already pretty happy with how the Flash side of our video player looked and worked, and we wanted to share it with some of our other properties. In addition, we wanted to rewrite our HTML5 video player to be an equivalent experience to our Flash version, because the iPad and devices in general becoming a bigger part of our audience. And the last thing is we wanted to expand support of the player to some new and legacy media types that these other properties use that we didn't. So the goals of the project, we wanted to leverage what we were already doing well, combine the resources, both in terms of developers and testing of the two different business units, and to be able to share that knowledge, to not have a single person or group as a point of failure for such a critical project, as well as support as many of the business cases that we could come up with for playing video on the site, and as well as allow the player to interact, to integrate with two very different content ecosystems, two separate CMSs, databases, and everything, as well as not be tied to either group's release schedule, and have a single code base for pushing out bug fixes and features, while still being fast and only loading the code that we needed. So here's some examples, and I have some wonderful screenshots of websites, but since we have a little bit of internet, I figure I'd show you guys. So this is the NFL.com video player. This is the Flash version, showing Dave Damashek's shame report. We've got a very minimal UI, and if I fast forward to the end here, you can see we've also got, maybe we don't have as good an internet as I hoped. Well, the internet is not going to be judicious to us today. Well, come on, internet's go. Anyway. We also surface some related content and integrate with our features such as NFL.com rewards. And here is our continuous play feature ticking down to play the next video on the list. In addition, this is the HTML5 version. I can show you this is Safari with plugins turned off, so there's no Flash available. And playing the same video, the UI looks pretty much the same. We've got some branding. We support full screen, volume controls, and all that, as well as the same features as far as promoting related content, continuous play, things like that. Oops. So how did we do it? Fast forward through these. And there are a few other business cases that we wanted to support too. Things like mid-roll ad breaks on the iPad, takeover videos with no Chrome, live and streaming audio, and Facebook embedding as well. Looking at our analytics, we chose these browsers to target as far as our, and to focus our testing on, because we had limited resources there. And the interesting thing is that most of the desktop browsers have gone into this auto-updating model, which has made it really easy to keep up to date with testing on them. But both in terms of devices and Internet Explorer, we're really stuck with testing on every single one of those different devices. And then as far as playback methods go, Flash, it used to be the way that all video was done. And now New Macs are coming without Flash installed on them. The iPad doesn't support it at all. And Android browsers, it kind of depends on the device whether you get Flash pre-installed or not. HTML5 video is actually much better supported. It's only on some of the older versions of IE. I even believe new IE 10 supports HTML5 video. But that doesn't tell the whole story, because unless you want to transcode your video into multiple different formats, the support looks quite a bit different. Chrome has talked about removing support for MPEG-4 video, or for H.264 video. Android, you're still not sure if it's supported, and Firefox doesn't support it at all. So we came up with a testing matrix where we would prefer Flash for a few reasons I'll get into in a minute, and support HTML5 on some of the other browsers that where we needed to. So fair warning, this is done in YUI 3.5. We lag a little bit behind the cutting edge in terms of our YUI version. And most of the solutions in here, they work for us, but and we're hoping that they work for you. If not, my Twitter handle is Dave Glass, and feel free to let me know. So the basic architecture of the player: NFL Video is a YUI module. The code is delivered through a collection of static files served via Apache, and PHP-based minify application compresses and concatenates both the style sheets and JavaScript. The module is included via a seed file, just like YUI, and the main class video.player inherits from y.widget. And when it's initialized, video.player actually detects the capabilities of the browser, figures out whether you support HTML5 or Flash or what to give you, and based on that, it makes a second call to get all the assets that you'll need to display the rest of the video. These are the 4 scenarios that we're supporting right now. Flash, obviously, and HTML5 for different playback methods. We also have the ability to force a user to upgrade their Flash player to watch video, and native to promote native viewing of our videos in some native applications if we can't show you in certain contexts based on some agreements that we have with some of our partners. And then video.player proxies its methods to the plugins. So this is our basic YUI configuration. Basically, we set up our own group called NFL UI and point at minify for all of our assets. And we define our module dependency tree here as well. For a developer that wants to implement the player, then the task is relatively simple. You create an empty div on the page. You load the seed file into the page. And those numbers in the URL, what they do is they trigger a behavior of minify that will actually send far future expires headers, which allows us fairly fine-grained control of when the caches expire on these particular videos. So when we force an update, we can decide to manually push all the users over to that specific new version. And those numbers are automatically generated by our build process. And then and then you can use the NFL video like any other module in YUI. Instantiating the video player looks very similar to instantiating a widget. We leverage most of the widget classes' configuration properties like height, width, and render, as well as providing some configuration both in terms of global site configuration to work on multiple websites, as well as the specific video ID that the developer wants to play. And we have a few other configuration options available based on some of the business cases of the player. So here's the full code example of what a developer implementing the player on the page would do. Controlling the player also supports several public methods. Here's some examples. You can load content into the player after it's been initialized. You can pause the video and play, seek. Pretty much anything that a user could do via native controls, we can also do via JavaScript as the page is running. So we have a lot of flexibility in terms of integrating with other applications that might be running on the page. We also support attributes like this is how our continuous play works, just by a developer toggling on continuous play, true or false. Events are also a core part of what the video player does. We support a huge suite of events that are published globally, and this tells other applications what the video player is doing. This allows us to integrate things like rewards to give users points when they watch a video, as well as allow the rest of the page to maybe dim when an ad plays or things like that. We have 3 layers of a configuration on the player. I've talked about them a little bit already. The placement is just attributes on the page. We also have a content-specific JSON file for each video that's loaded that tells us everything that we need to know about how to play it. So that includes things like the title of the video, CDN data as far as where the actual file is located, and things like that. And then each site has its own JSON file as well that loads in data like branding, some specific business requirements around which CDNs to use and whether we should load balance them, and things like that. Each one of these web services is wrapped around y.base. And and we do that to create a class locally on the player rather than just interacting directly with the JSON. And we do this for one major reason, and this is for documentation. So we use YUI doc for this player. Pretty much all of the code in the player is documented this way. And this is an example of YUI doc Dave went over a little bit earlier. And we found this to be a great tool. Just by running a simple line of code on your script, we generate a whole website where new developers to the project can get access to what the video player does, how it works, and begin to have a good insight into how the code all fits together. And we found this to be a great help in getting new developers into the projects. We have a similar application called ASDoc that we use that comes bundled with the Flash player. It works very similar to YUI doc, but it does introspect parameters and return types in Flash, which is very nice, but it's also kind of grumpy. It will warn you for things that the Flash compiler doesn't warn you about and fail to compile your documentation. And it's actually really slow. Using ASDoc for a little while, you'll become very, very enamored with YUI doc for JavaScript. But the code looks very similar. And it generates a source, a documentation site, just like Adobe does it, we use for this. So talk a little bit about Flash. So I know this is a JavaScript conference, but in terms of video, Flash isn't going away anytime soon. There's a couple reasons for that. There's a lot of things that Flash can do that HTML5 video just isn't ready for yet. You can't protect content in a Flash or in HTML5 video. Flash or HTML5 can't stream to all browsers yet. There's millions of hours of online video that's been encoded in formats that HTML5 can't play. And HTML5 doesn't yet have an event interface for embedded metadata. So if you're trying to encode data about what's actually on the screen to your video player, it becomes very difficult to react to that. And you can't choose a bitrate for the user based on their actual connection and speed and whether or not they're dropping frames, which we do in Flash. Flash also has very robust control over your connection. You can find out all kinds of quality of service information, and it has a lot of vendor support right now as well. But that's not all bad. One thing we talked about is using Flash as a polyfill. So for the browsers that don't support it, add a small Flash layer that replaces the video element and use that instead. But we already had a Flash player that worked, and so that was one of the main reasons we decided not to do it. And the second reason not to use Flash as simply a polyfill is Facebook. So Open Graph, if you want your videos to play inline in the content stream, requires a self-contained Flash video player. You can pass it parameters, but if you provide an HTML URL, it's just going to redirect to that page. And this was a valuable thing for us. But that's not bad because YUI has great Flash support for the most part. Y.Swift is the class that you use to embed Flash in websites. And it allows you to fire native YUI custom events directly from ActionScript. And this is really cool. There's some great examples in the documentation around using the YUI bridge class And the end result is that in your Flash code or in your JavaScript code, you can just listen for events. And as well, there's also the ability to call external interface methods from the Swift instance, or from the y.swift instance directly back into ActionScript. So you can have two-way communication between your Flash movies and your Flash movies and your page in pretty much exactly the same way that JavaScript does. And that allows us to really hide the actual implementation of whether you're watching Flash player or an HTML5 video player behind this event interface. There are a couple things that we had to work around in using y.swift. The main ones are that YUI's express install feature, which is how you have a user upgrade their Flash player, doesn't work. There's a bug in it in the YUI ticketing system. It's been targeted for a while. But there's a good workaround, and that's to use Swift Objects express install Swift. Swift Object is another open source video Flash embedding component, and it'll do the trick. And then y.swift also doesn't have a destructor method, so if your application involves creating and destroying a lot of Flash movies, you're going to want to be careful, and we wrote our own destructor in order to handle that case. So talking about HTML5 video now. Our HTML5 player, the plugin that renders the HTML5 video, has a model view controller interface. Summarized here. We extend y.base to wrap those JSON web services. Our views are all inherit from y.widget, just like the main player does. And our controller is, and what I consider the controller is just a single attribute called state and a whole lot of events and event listeners. So the models I'd mentioned a little bit before, they allow us to create awesome documentation. They allow us to set some great defaults for our properties, so we don't have to have two, so we can have as minimal of an API as possible. And I'm not going to go too much into them, but they work great. And then our views are all widgets, and they're all stacked on top of each other, just using absolute positioning. We have the poster frame that loads in the, well, starting with the video element, and then we have the poster frame that loads in the image assets for that video, the actual controls that the user can interact with, an end state, an error state, and a loading state. These are all just, they inherit from y.widget. Our time codes are done with slider, and they're all fully integrated with YUI. Stack of subviews. So this is an example of just how we instantiate that. We have a single widget config. We use the width and height from the host, and we all render them right into the content box. And we use widgets built-in visibility method to show and hide those modules. And we just use CSS to actually handle the showing and the hiding. One of the reasons why I really love widget is its render lifecycle, I feel, makes a really approachable structure for a developer to learn about a new module. So when you call render on a widget, it calls these three methods: render UI, bind UI, and sync UI in a row. And by default, none of them do anything. But it provides a great gateway for you to organize and structure your code. And so this is an example of how we handle that. For an example of an attribute called headline, we render the DOM in the render UI method. We give it a specific class name. And then we have an event handler for headline change. And for bind UI, we set that handler. And then when sync UI runs, we actually call that exact same event handler with the new value set to the current value that the player needs to mimic. And this, we use this pattern all throughout the player to keep state in our views. There's also, we also skin all of our views in CSS using the skinnable property in Loader. So every view is its own module, and by setting skinnable to true and setting up our folder structure like this, we get automatic loading of CSS files specifically for these modules, which allows us to keep our code modular and organized. We generate all of these CSS files using Sass. And we use widgets get class name method a lot to keep our CSS very flat. This allows us to have minimal nesting, which keeps our selectors nice and fast. The browser doesn't have to search up the DOM tree for different class names. And it also prevents styling conflicts lower on the page if we specifically target these classes. The one main benefit that we found to using these widget subviews is how well they can be tested in isolation. So I've got a screenshot here, but I've got an even better live demo here. And so this is our controls widget, and you can see I can show and hide, and these are all the. Let me reload this guy. No. There we go. So I'm being foiled by my my awesome event listeners. So as I can change the attributes on this, I can change the attributes easily, and the rest of the UI will react to. So I can set the current time to 1,000 seconds, and we'll get duration to 1,000. We can see we get progress bars, sliders, and things like that. And this makes visual verification and finding CSS bugs for things like this really easy. The main attribute for our, the HTML5 player class is state. And we've got some predefined variable shortcuts for each of the states. And state acts as basically a traffic cop for the entire application. So whenever the state change event fires, we switch through the previous and next and new values of the attribute and clean up or toggle on or off views that need to come up. And we use events, custom events in the player quite a bit, and these allow the different modules to interact with each other on the page. So when the video node fires a playing event, we fire our own custom play event. This play event is the same. We use variable shortcuts for this because it also is normalized with the Flash events as well. Interacting with the legacy Flash event names made it easier to read and see rather than putting all these strings in our code. But that event is then listened to by our omniture tracking controller to send a tracking event to our analytics suite. And we use this throughout the player as well. One thing about YUI's custom events is that there's 4 ways to register events. And I think this is really important for developers working on YUI to really get to understand is that the on and after phase of events, on is fired as the event is happening. On lets you prevent the event from occurring if the event is customized as preventable. And after happens after the event has already occurred and has successfully gone through all of the other on event handlers. And so my recommendation is to pretty much always use after if you are actually interested in knowing that the event happened rather than on, so that if a new feature later on has to interact with that event and perhaps stop it, then you don't have to refactor old code to say, oh, actually, I don't only want to know if this was successful or not. And we do this, and here's an example of us leveraging this. When a user hits the play button or a developer calls the play method on the player, instead of actually manually starting the video playback at that point, we fire a play request event. Its default method actually then sets the state to playing and plays the video. And so this way, something like our advertising controller can listen for that event, cancel it, and then show a pre-roll ad. So let's talk a little bit about ads. Ads are generally pretty easy. We use Google's IMA SDK. Its API is very similar to the Flash version, which is great. It's robust and it's well documented. They've got some really great examples. The workflow is simply you create a URL-based ad request. You handle events fired from these IMA ad objects. And you pass the object to your video player, and it manages juggling sources. And then for tracking clicks on ads and launching sites, you just put an invisible DOM element over your video, and the framework handles the rest. But ads aren't always easy. They can be really tricky too, because the bugs can occur at many levels. Advertising infrastructure is really labyrinthine, and there are all sorts of places that the code can break in yours, in the library. We keep finding new and interesting ways for ads to fail. Sometimes error events will get fired. Sometimes an exception will get thrown. Sometimes nothing at all will happen. And when you're implementing ads in an HTML5 video player, you've got to be prepared for pretty much anything that could possibly go wrong, because odds are it will. And debugging ads is really difficult. You can't introspect the IMA's ad objects. It's really tough to figure out what's going on. And so yeah, just try and plan ahead is my advice. And then one other thing that we found is that on iOS, when you click on an ad, the video pauses, but then you have to make sure to handle the case when the user comes back to the page. If you've hidden your play and pause controls for ads so that users can't skip them, then they've got to have some way to get back into the video and continue playing the ad when they come back. And there's no event that iOS surfaces for you to be able to notice that. And then one other thing that broke for us was that companion ads that you put on your page, they come in as a div filled with HTML, and those can sometimes conflict with your DOM, especially if you're using rich media ads. So I recommend creating an iframe dynamically and loading them on the page that way. Third-party dependencies like IMA's ad framework. Last year at YUIConf, I came and said that there were two things that we still had to figure out. And the first one was working with third-party JavaScript, and I've come up with a solution that works pretty well for us now. We wanted to make sure that we didn't load the same library multiple times, that there were multiple instances of the player on the page. We wanted to avoid race conditions when these libraries load things asynchronously. And so the way that we solved it, or this is the standard way that Google's documentation suggests that you load it, is to include a seed file, set a load callback, and then load the video, and eventually this function will get called. So what we wanted to do is create a wrapper around this that the function loads Google IMA if it's necessary, and then that callback gets called once the library is actually ready, and that you can call this function hundreds of times, but the library will only get loaded once. And the way that we actually built this was using YUI's event infrastructure and specifically the y.global instance. Y.global is shared between every instance of YUI that's created on the page. And so what we listen for is when this IMA loaded event is fired, we call the callback that's passed into the function. And you can return an event handler to detach if you no longer become interested in it. And then if the custom event doesn't already exist, then you just publish that event and tell it to fire once. And then new event listeners will be notified as soon as that event, or the next time a function comes through. If the library is already loaded, then the new listeners will be notified right away. And then we load the IMA library one time. And this is just an example of doing that and then firing the custom event. All right, so the second thing that we had yet to figure out was building a font service. If you notice on our HTML5 video player, we have some of NFL's custom fonts in the UI. And YUI web fonts, for most use cases, for the 80%, they work really well. You define your font, you set styles, you it can include multiple formats in order to support all the browsers that you need. And then you just use that font family name in your CSS. But this approach has some drawbacks. The first one is that font files are big. They can, a full font, even of just US ASCII, can get around 30K is what our files are running. And they're loaded whether the browser renders them or not. So if you have a lot of different typefaces, including them in a global style sheet, it's going to incur a lot of cost in terms of downloading the files. If you try and load them asynchronously, what your files will do is you'll see the default font for that element show up, and then your page might bounce around a bit, and then your font will load in, and that's no good either. And then lastly is if your web fonts are reloaded every time they are defined, causing elements on the page to flicker. So if you've got a web font statically defined on your page and you're happy with it, and then you have a module that's sometimes loaded on the page, and that module also defines that same font, it'll cause that file to re-download, the content to disappear and reappear. It looks kind of gross. And so we're using YUI and Loader as a web font service. So what that means is that we define a module called for the font, just a style sheet that has all of that font definition in it, and then we can use that module as a dependency for other ones. So our controls require this font, so we define it, and then it's automatically loaded when the page loads. And then if the page itself has a static font requirement, all we need to do is define that, load that style sheet on the page as well, and then call YUI.add for that module. This registers that the module is loaded with YUI, and it'll only be loaded exactly one time. And this is an example of all of the font files that we're supporting, and we're building this out and potentially using it to share with our other partners and vendors as well to help them match our branded experience when they want to. The last thing that we needed to do to really make video work with YUI is add support for HTML5's media element. So media element is the API for both the video and audio nodes that's been newly defined in some of the later HTML specs. And it's not natively supported by YUI. So adding event support was actually pretty easy. There's a property of node called DOM events, and if you add more members to that node, to that object, those events then become natively supported. So adding this one line to the DOM events for the playing will allow YUI to listen for the playing event fired from a video element. And since we built this, or since we did this ourselves, we then later on saw YUI do the same thing in this node event HTML5 module. But there are other methods on nodes, on media nodes that other nodes don't support, like play. And so this is an example of how to add a play method to the node instance. And all it does is proxy whatever arguments the element receives and calls them directly on and return the return value. And we did this for play, pause, can play type, which detects format support, and request full screen and cancel full screen. And then full screen was a special case because the API for full screen hasn't been completely defined yet, and all the browsers implemented it a little bit differently. But they were similar enough that we could abstract them into a single API. And so we added full screen support by defining an object with properties of test is full screen, request full screen, and cancel full screen, and the event name of the actual full screen event that the browser fires. And then we just loop through each one of those and return the first one that the browser supports. And if it finds any support at all, then supports full screen is set to true. Otherwise, it's set to false. All right, I'm running a little bit out of time. I'll talk real quick about testing. We struggled with testing. We've always done just visual verification for NFL.com. We have a QA team that is fantastic and works really hard at finding our bugs. And we set out with a goal to build an entire test suite for this video player in using YUI's test framework. And But we had some trouble with it. We built some awesome test pages, but our stub data was really hard to manage. When a test passed, it didn't necessarily indicate that the implementation was correct. And as the project went on, we found out it was testing was taking more time than it was actually saving us. And so about midway through the project, as deadline pressure mounted, we decided we needed to change our approach. And this actually made Dave's presentation this morning about Grover and Yeti, I'm really excited about, because I'm hoping this helps us do what we haven't been able to do yet, which is get this automated testing part finished out. All right, I'm going to skip some of this stuff. And some of these slides will be available, so you guys can check them out for some of the stuff that I skipped. Two things that I still have left to solve, because I can't leave any answer completely finished. Module name collisions. When you're defining YUI as a web service, you have to or a web service that leverages YUI, you have to realize that if a module name is already defined, you can have module name conflicts, and we don't really have a great way yet of resolving those. There's no name spacing of groups or anything like that. And then the second one is that if you're trying to integrate on a page that already has YUI and you guys are both using different versions, there's really not a great way to resolve that. This is kind of a contrived example because no one would ever write code like this, but it shows that if you have two different seed files loaded on your page, you might get something unexpected, which can be problematic. And then I'm just going to finish up with a shameless plug. If you find this stuff interesting and the problems that the NFL is trying to solve, we're hiring. So we're looking for developers. We work out of Culver City in just outside of Los Angeles. And if you're interested, you can come talk to me after this presentation. And these are some of the positions that we have open on our official jobs page, and there's plenty more available too. So this is some credits of the stuff that I included, and then I'm ready to open up for questions. And you can see slides, examples, and some other things on the website for this project.
So we can open it up for questions. There we go. Thanks. Hey, so I noticed that you checked the y.swift object. Have you ever run into problems with the y.swift detect, or like if the Swift is at least Flash version of a certain amount?
We found a version, a bug. I don't know if it was a bug or, but it was an incompatibility with Flash 10.0.0 and IE. And so our Swift detect logic actually has a code fork where it says, if the browser is IE, then require at least Flash 10.1. Otherwise, force them to upgrade, and then, but all other browsers we support all the way back to Flash 6 to force them to upgrade.
And then are you going to go ahead and download the 3.73 to get the new IE10 guys compatible with YUI? Because as far as I know right now, I think if you're on anything less than 3.73, I don't think IE10 will work very well.
Will we? Yes.
Okay. What does it do right now? I'm just curious. Have you tested it?
We haven't tested it yet.
Okay.
Could you go over your font solution again? I missed it. I saw the setup to the problem, but I missed what you did to solve.
Sure. I can back up just a little bit. The main thing we did is we define each of the fonts in their own style sheet, and we define them in modules in our own YUI group. And so what this does is that style sheet contains no logic other than just the font face definition. Then other modules can add that module to their requires list. And so when we request for NFL video controls here, it'll say, oh, I need the fonts end zone sans font CSS, so I'll go get that first. And then the second part of that is that if the actual page has static HTML elements that always require that font, then you need to embed using the standard link that same font file. And we have some tricks to actually concatenate the font files together. So, but that's not really relevant to this code example. And then by calling YUI.add on the page and just passing in an empty function, then YUI registers that module as having already been loaded and doesn't go get it again.
Oh, so you had trouble with it reloading?
Right, yes. Every time, this prevents you from loading the font file again after the font has already been loaded on the page, yeah.
That was happening after the at font, whenever there was an at font space declaration?
When you have the font file loaded, or the font defined statically in another CSS file, or embedded on the page in a style block, or any way that a font can get loaded, and then a module that's conditionally on the page, like for example, sometimes we throw our video player up on the home page. The home page doesn't already have that font on it, then we have to go get it. And so we wanted to make sure that we could do that without risking reloading the font and having all of our styles flash all over the place.
Great. Do we have any other questions? Okay, can we give one more big hand for Ryan Glenn?